Welcome everybody. In this video we're going to be looking at friction. By the end of the video you'll be able to define friction and describe its effects on motion. So friction is a force that acts when two surfaces are in contact and rubbing against each other. The friction force always acts to oppose any motion. So if I'm trying to push the purple box to the right, the friction will act to the left. But if I try and push the purple box to the left, the friction will act in the other direction and push to the right, always trying to slow the motion down. And if I'm not pushing the box at all, then there won't be any friction. If we take a close look at the interaction between those two surfaces, we would see that it's the roughness of the surfaces that creates the opposing friction force. Friction can sometimes be helpful and sometimes harmful. For example, this car relies on the friction between the tyres and the ground to get its grip to move forwards. In a similar fashion, these people are using the friction between their hands and the rope to climb up. However, if they were to slide down that rope, then the friction between their hands and the rope would burn their hands, and that's obviously an unhelpful example of friction. Let's consider some crazy idiot who wants to jump out of a helicopter. You might not think there's any friction at all when you're falling through the air, because in day-to-day life it doesn't seem like the air's got much resistance. However, there are air particles there, and as you try and move through them at fast speed, they will act as a frictional force to slow your motion down. So when this guy first jumps out of the plane, for a split second he's not moving at all, and so therefore there's no friction or no air resistance. However, as soon as he starts to move, there will be a friction force. And you can see here, to start with, the air resistance has got a frictional force of 350 newtons. That means overall, the net force is now slightly less. As he moves faster, the air resistance gets bigger. That means the net force is getting smaller, and so he's now accelerating at a slower rate. And eventually that air resistance force will become so large that it is exactly equal to the gravitational force, and therefore there will be no acceleration. So if we look at these forces as we go along in these four diagrams, we can see the gravitational force is constant the whole time. As he starts to move faster, the air resistance force gets bigger, which in turn makes the net force smaller, until that net force is zero and he's not accelerating. He is of course moving, he's falling quite quickly, but because he can't go any faster, we call that terminal velocity. The only way you can overcome terminal velocity is to change the shape of your body or to make yourself more massive so that you've got a larger gravitational force. What if we take away the air altogether? Well, the Apollo 15 astronauts tested this. They took a hammer and a feather and they dropped them on the moon. Now if you do that on Earth, obviously the hammer's going to hit the ground first. However, without any air, it turns out that they actually accelerate at the same rate. This is because there's no air resistance to change the size of the net force. Here on Earth, the net force acting on the feather is zero, because the weight force is equal to the frictional force or the air resistance. However, for the hammer, the weight force is a lot bigger than the air resistance, therefore it has a large net force, therefore it accelerates quite quickly. However, on the moon, there is no friction force, no air resistance, and even though the hammer has got more mass, and therefore a greater weight force, it also has larger inertia. So it needs that bigger force to accelerate. In contrast, the feather's got a smaller mass, therefore a smaller weight force, but that also means it's got smaller inertia. So in both cases the acceleration is the same, and they will hit the ground at the same time. So now you can describe friction, and describe the effects on motion, including how air resistance affects objects that are falling. Thanks for watching.